Hey guys, it's Mr. Hebrack, and I am here to show you some notes for section 2.1. Most of you are going to see this in class, but just in case you missed it, I want to go over this with everyone so we're all on the same page. First of all, I want to show you about solving linear equations. Now, you spent a lot of time in algebra learning all about one-step equations, two-step equations, what do you do when you got the variable on both sides, all that stuff. You're in Algebra 2 now, so we're going to assume that you know the basic order of operations and how one goes about solving an equation, and we're going to give you some stuff that's a little bit more complex. That doesn't mean you can't do it. It just means that you might have to take a couple extra steps in order to get through everything in a reasonable amount of time. So here on this page here, I'm using the additional notes packet that is available in the Chapter 2 folder. There's also the Chapter 2 notes packet that you can refer to. We're going to be jumping back and forth between those packets in this chapter. Here we have two examples. This first one here uses the distributive property, where we have 8 times y minus 6 equals 64. So they distribute, multiply 8 times y, 8 times 6, and then they solve for y. Now, I'm going to show you another thing you can do. You don't have to distribute. In fact, if you recall, when I'm multiplying, the opposite operation is division. So I could just divide both sides by 8. And if I know I can, this is what I'm going to do. And this is going to give me y minus 6 equals 8. Then all I have to do is add 6, and I'm going to get y equals 14. And you notice these answers here are the same. So you can distribute and then solve, or you can divide and get rid of that number in front of the expression and solve that way. This second example here is about combining like terms. Again, you just gotta do the math. Here we have 4x plus 18 minus 3 and 3x minus 45 plus 5x. Well, on this side of the equation, the x's are like terms. On this side of the equation, the constants are like terms. Constants are always going to be like terms, but in order for variables to be like terms, remember, you have to have the same variable with the same exponent. So anyway, we combine them and we get 4x plus 15 equals 8x minus 45. Now they say subtract 4x from each side, and that's what we're going to do. And the reason why I like to do that is I always like to subtract the smaller from the larger. Subtract smaller variable from the larger. And since 4 is smaller than 8, I'm going to do that. The reason why is I want to try to keep the coefficient on my x term here to be positive whenever I possibly can. Doesn't always work, but if I can, I'm going to do that. So we get 15 equals 4x minus 45. I'm going to add 45. I'm going to divide by 4. I get x equals 15. So that is basically what we're going to do. Let's work out a couple of these. Number one here, we are going to distribute because they've kind of already set us up for that. So 3 times x is 3x, and 3 times 9 is 27. I'm going to subtract 27. And reach for my calculator here. 63 minus 27 is 36. And then I'm going to divide by 3. 36 divided by 3 is 12. I'm going to skip over to number 3 here. Instead of distributing, I am going to cut straight to dividing. And that's going to change things a little bit on this side. But 168 divided by 8 is 21. So really I'm going to get w minus 6 equals 21. I'm going to ignore that guy. And then all I got to do is add 6. So I get w equals 27. It's just that simple. Let's look at combining like terms. Combining across, I got 5a plus 3 equals 2a plus 9. I'm going to subtract 2 from each side because 2 is smaller than 5. That's going to leave me with 3a plus 3 equals 9. I'm going to subtract 3. I get 3a equals 6. Going to divide by 2. And I get a equals, or divide by 3, sorry. Getting ahead of myself. Divide by 3. And a is going to equal 2. Here I have some like terms. I'm going to combine those so I get 9y equals 3y plus 30, because 8 plus 1 is 9. Here I have no choice. I only have y's on the right hand side, so I have to subtract 3y, or left hand side. It'll help if I remember my directions. 9 minus 3 is 6y. Going to divide by 6. And I get y equals 5. Here I have x plus 5 equals 29 minus 3x. Now, technically 3 is more than 1, but this is negative 3. So it is smaller. So I'm going to add 3 to each side. So I get 4x plus 5 equals 29. If I subtract 5, I end up with 4x equals 24. And if I divide by 4, I get x equals 6. So those are equations. Remember that inequalities, here on the next page, inequalities, because we didn't talk about those yet, you have to do this. Reverse the inequality symbol if you multiply or divide both sides by a negative number. Only going to do that if I multiply or divide by a negative. So if you look here, and I don't know why they do this because this is not what I would do, but they have x minus 3 is less than or equal to 5x plus 9. This goes against what I've recommended you guys do. I would move the smaller x to combine it with the larger, but that's okay. We're going to go with it and see what happens. I'm going to subtract 5x from each side. I get negative 4x minus 3 equals 9. I'm going to add 3. So I end up with negative 4x is less than or equal to 12. I'm going to divide by negative 4, and then this is the key right over here. I am going to reverse my inequality from less than or equal to greater than or equal to. And then you got to remember to graph it. Now if you remember back in chapter 1 we talked about our interval emojis. Those work here too. Remember that you're going to have open circles for less than or greater than, and you are going to have closed circles for less than or equal to, greater than or equal to. The thing about inequalities is you kind of have to represent your answers using a number line. And they do recommend checking. Yeah, sure, I guess you could check, but whatever. Alright, so again, they're creating a situation here. 2x is greater than 8x minus 24, so we're subtracting 8x from each side, so I'm going to get negative 6x is greater than negative 24. So here's what's going to happen. I'm going to divide by negative 6. And when I do that, notice what's going on here. The greater than is going to become less than. So I get x is less than negative 6. So if I want to draw that guy on a number line, this is just real quick. Open circle, arrow going to the left because it's less than. Here we have the number 8. 5w plus 2 is less than 8w plus 23. I guess they want to keep your variable on the left-hand side. Whatever. They're subtracting 8w from each side, so we get negative 3w plus 2 is less than 23. I'm going to subtract 2. So we get negative 3w is less than 21. And then I'm going to divide by negative 3, which is going to reverse my less than to become greater than. So we have w is greater than negative 3. And again, very similar number line here. There's negative 3. I'm going to have an open circle. This time, since it's greater than, I'm going to point to the right. 7y minus 1 is greater than 12y plus 29. All right, I'm going to go with their flow here, and I'm going to subtract 12y from each side. So that's going to give me negative 5y minus 1. It's a y, trust me. So that means I'm going to add 1, and I get negative 5y is less than or equal to 30. So now when I divide by negative 5, the greater than or equal to becomes less than or equal to. And I get y less than or equal to negative 6. So again, on the number line here, there's negative 6. This time my circle is going to be closed, and my arrow is going to point to the left. So that's it. Just remember, you only do this when you divide by a negative. All right, if I divide by a positive, there's no change. Okay? You only have to worry about changing or reversing the inequality symbol when you divide by a negative. You could also possibly be multiplying by a negative. And that's it. All right, so that's it for lesson 2.1. Next up will be lesson 2.2. That's how the things go, math. If you like this, great. If you learned something, smash that like button and let me know. And I will see you all in the next one.